difference between metals and non-metals, and we are going to talk about the transition metals. Those metals located here in this section, they are called transition elements or transition metals. Yes, we are going to start to define the metals, the non-metals, and after that we are going to continue with the classification of the materials in two big brains, in organic materials and inorganic materials. Carbon, silica, and germanium. Those three elements are located in the group number 4. Those elements produce excellent structure because the people ask about why the carbon fiber and the fiberglass, the structure is strong. Let me demonstrate why. Suppose that we have a carbon fiber. We have the structure of the mat of carbon fiber. That heavy structure is basically carbon, atoms of carbon together. Let me check what happened in that structure. I have carbons, I have carbons, I have carbons, pure carbons. And let me verify how many electrons have a carbon in the last orbit. 4 electrons, no? According with the periodic table, it's located in the group number 4, is 4 electrons. The majority of those elements located in this group, in between this point and this point, in between scandium and copper, they work in the last orbit with 3 electrons. And only this small group, zinc, cadmium, and mercury, they work in the last orbit with 2 electrons. This is very, 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 very important. For that reason, the elements located here are considered non-conductors, non-metals. Non-metals. You remember the division? Non-metals. The non-metals in the groups 6, 7, 8 are bad conductors, non-conductors. And we are going to create the oxide of iron. When the oxygen attacks the metals, produce oxides. This is other important consideration, my friend. I explained that the metals, all of them are excellent conductor of electricity. Yeah. However, when the metals are attacked for the oxygen, for example, you remember when you have a piece of aluminum and you put the aluminum outside in your home for 3 days, expose it to the rain and the sun. In 3 days you touch the aluminum and you found it like a white powder. That white powder is oxide of aluminum. You need 2 atoms of iron per 3 atoms of oxygen to create that molecule. The molecule of oxide of iron. That molecule is stable. Yeah, but it's a lot of combination, no? It's 2 irons per 3 oxygens. Yeah. Let me check what happened in this particular. How is that formula? I have 3 oxygens. I have 3 oxygens, and I have 2 irons. And the iron have 3 electrons in the last orbit. The iron have 3 electrons in the last orbit. And let me check the oxygens. The oxygen have 6, no? The oxygen have 6 oxygens in the last orbit. 6 oxygens in the last orbit. And each iron, each oxygen needs 2 additional to be stable. What element have more energy in that combination? Oxygen, because oxygen is located in that corner, and iron is located here, less electronegativity. Oh, the element with more electronegativity, with more energy, absorb the electrons. In that case, this one and this one migrate over there, and this one migrate here, this one migrate here, and this over there. That's perfect. And now the molecule is stable, and this is the molecule of oxygen. Can I protect the metals in my boat with other metal different like zinc? For example, what happened with the metals located here, zinc, cadmium, and mercury? All of those, they work with 2 electrons in the last orbit. They have a similar function like the zinc. Yes, but there are a couple of inconveniences with each of those metals. With cadmium, one inconvenience is poison, and other one is too expensive. It's used in high quality batteries. We are going to talk later about that. The cadmium batteries. Yeah, it's too expensive. Zinc is cheap. You found that a lot of zinc in the environment is not expensive. What about mercury? Mercury in natural state is liquid and also is poison. What about the elements in the group number 2? Beryllium, magnesium, calcium, strontium, barium, radium. Those metals can be used to protect other metals. They have 2 electrons in the last orbit. But those metals are alkali metals. And those metals react with water. The only one that not react is magnesium. Yes, magnesium is commonly used like a sacrificial anode to protect other metals. Magnesium is commonly used in fresh waters. The ferrous alloys are based on iron, and the non-ferrous alloys are based in other metals different than iron. The alloys of irons are a million of alloys, steel, stainless steel, but the most famous is stainless steel. You remember how can you identify if a bolt is a good stainless steel or not? You remember that micro video? Yes, it's with a magnet. Yes, if the magnet not attract that bolt, it's because this is a good stainless steel. This is a marine grade stainless steel. And the element in the alloy, because this is iron. That alloy, stainless steel, is iron with carbon and other important ingredient, chromium. Chromium. The chromium inhibits the magnetic properties of the iron. If the amount of chromium is in between 12% and 16%, the magnetic properties of the iron disappear.